This is our final project for CCS 525. This is our automatic chicken coop feeder. It consists of a camera that's hooked up to two servos that control the position of the camera. The servos are powered currently by this power supply. It consists of a automatic door, which the door opens and closes based on sunrise and sunset. These LEDs currently represent the state of the door, where the right LED is on, the left LED is off. Its audio is hooked up to these speakers to play a sound when the automatic feeder activates, and it's hooked up to Ethernet to serve the web server, which the Raspberry Pi, which you control all these controls from. So this is the website. You start by logging in, and here is the video feed. Whoa. It has about a 10-second delay, which is why you just saw me videotaping. And it consists of the video feed, and it consists of the controls. So the controls are used to control the GPIO outputs, and really, that's what they're for. So you have the status, you have parameters, and you have a description of what the control actually does. So you can edit the tooltip, you can edit the parameters, you can edit the name of it. You can turn it on and off. So when you turn it on and off, it updates a SQLite database hosted on the .NET Core application. And this is the front end. This is an Angular 2 application. And then the Python script consumes that GPIO control. It pulls the server, and it will update the GPIO controls accordingly. So right now the parameter state when off is closed, and right now the door is open. So if I were to turn this off, the LEDs will flip, and the status will update to the door is being forced closed. We turn it back on, and now we have the door is opened at the current time. So, and in addition to that, we have the move camera. So these parameters are in degrees, and when you turn on the camera, or when you turn on the move camera control, it moves the camera and then turns itself back off. So this will, if we edit the parameters to 0 horizontal degrees and 180 vertical degrees, let me save it, and I activate the control, the Raspberry Pi will move. And then we have the feeder control. The feeder control turns on a motor which spins this. The motor controller, I don't have the motor controller board, I left it at school, but this would turn from a 12-volt motor and spin, which would dispense food, and it also plays a sound from the speakers 3 times, and you can control the time on by the parameters. A cool thing about the GPIO controls is that all you have to do to add a new functionality to the Raspberry Pi and witness it from the webcam is just by adding control and then implementing it in Python, which is just a matter of consuming the object and updating the object. So it's really simple to add a new control. You don't have to mess with the front end, you don't have to mess with the back end. Just add a new control and edit the Python script. The webcam is, the video feed goes to the Raspberry Pi, FFmpeg encodes it, and then using the Raspberry Pi's hardware decoder. So the CPU utilization when you're encoding the video is really low because it's using the hardware decoder, and that allows me to do other things. Otherwise it would be at 100% and the video would be way lower quality. you could probably push 30 FPS at like probably 720p or something with it. I haven't exactly tested it because this webcam isn't really. It's only like 480p. So from there, the video feed is served to Nginx RMTP server, and then it's converted to an HLS stream. The HLS stream is served behind authentication using .NET Core. So the video stream is authenticated, as well as all these other GPI controls. They're served from the authenticated API. So yeah, .NET Core backend, Python script controls, GPI controls, and Angular 2 is the front-end UI, and it's all served behind the reverse proxy Nginx. And that consists of the stack. That consists of the project. I'm kind of disappointed that I forgot to bring the motor controller, but you know, it's something you can turn on the camera. You bring it to the website. You know, you turn on the feeder. You watch all the little chickens that have been conditioned by the sound, and they come running over and they start eating all the food. And you get to watch them. You can show it to your grandma. You can show it to your grandpa. You know, your mom, your dad, your coworkers, your boss. You show it to the whole world, as long as they're authenticated to the backend. So you know, it's a neat project, and I'm glad to have had the opportunity to work with the group and complete it, because it's kind of been an idea that I've been holding on to for a while. And yeah, gonna kind of give it to my dad as a Christmas present. Gonna have to buy a new probably buy a better feeder. This was just kind of for a demo, even though we didn't even get to demo it. But you know, proof of concept, it spins, right? So yeah, that's it.